This is a presentation of the Kaydon Hi-Vac 858-600 or the Blue Goose. Our goal is to help you learn and understand the components of the Blue Goose. Let's begin with the manufacturer's flow diagram. The first thing we see is the Y-trap. The Y-trap is a screen filter that catches any large particles that may be in the oil. The Y-trap is located on the wall next to the Blue Goose. Next, we have the feed pump. The feed pump draws the oil out of the tank and into the machine. After the feed pump comes the pre-filter. The pre-filter removes some of the carbon and particulates from the oil. The feed pump is equipped with a fluid bypass line. The bypass returns from after the pre-filter to before the feed pump. The valve is preset at the factory. Now we're moving the oil through a pre-filter, but we haven't done much to remove the moisture from the oil. What can we add that would cause the moisture and saturated gases to evaporate out of the oil? A heater is placed after the pre-filter to cook the moisture and gases out of the oil. It is usually set at about 110 to 130 degrees Fahrenheit. If we heat the oil without allowing the moisture and gases to evaporate into the atmosphere, what would happen? They would dissolve back into the oil upon cooling. What can we add to allow atmospheric release? The manual calls it the process chamber, but I'll refer to it as the vacuum chamber. Let's look at how the vacuum chamber works. Our heated oil enters the chamber, goes through the lower chamber into the center chamber, which feeds the dispenser elements. This is a view of the vacuum tank interior through the porthole. The oil enters from the heater, goes through the hose and out to the elements in the top chamber of the vacuum tank. As the heated oil passes through the 20 elements in the upper chamber, the moisture and saturated gases are released and are vented into the atmosphere. Here is a look at one of the elements. There are a total of 20 of these elements inside the vacuum chamber. After passing through the elements, the oil is gravity fed into the lower chamber. Here is a look inside the lower vacuum chamber. Now we need to get the oil flowing again. Let's add a pump to remove the oil from the lower chamber. Here is our discharge pump with a bypass with valve that regulates gallons per minute output. As with the feed pump, this is also preset at the factory, so no adjustment is needed. In photo 1, you can see the discharge pump as it relates to the main vacuum chamber. The oil is drawn from the vacuum chamber at the bottom. Photo 2 shows the bypass hose that returns to the vacuum chamber. But how can we regulate the output so that it keeps the chamber oil at a consistent level? Here we see the high-low level switch. It is an electrical A-B switch in the chamber that controls the discharge pump. Here is a look at the high-low level switch inside the vacuum chamber. What could we use to control the flow of oil into the chamber? The float mechanism is a mechanical valve that opens and closes in reaction to the oil level in the bottom chamber. So as the oil level rises, the float restricts the inflow of oil. As the level lowers, the float valve is opened, allowing maximum flow from the feed pump. Let's pass the oil through one more filter before returning it to the tank. We'll call it the post filter. The post filter removes particulates and carbon just as the pre-filter does. And now we've gone through the entire machine. Let's take a look at the entire diagram. We start with the Y valve, go through the feed pump, into the pre-filter, then the heater, then the inflow of oil gets regulated by the float control valve, then goes through the dispenser elements in the vacuum chamber, where the evaporated moisture is removed. As the moisture is removed, the oil then is pumped out of the bottom of the vacuum chamber. This is done by the discharge pump. The oil then goes through the post filter and back into the tank. What could we add that would speed up the removal of the moisture and gases from the chamber? If you said a vacuum pump, you're correct. When water is introduced to a vacuum, it turns to steam at a much lower temperature than the normal boiling point of water, which is 212 degrees Fahrenheit. The vacuum unit can hold the vacuum chamber between approximately 0.5 and 2 torrs. When the oil is heated to between 110 to 130 degrees Fahrenheit, the water turns to steam inside the vacuum chamber and separates from the oil. 1 torr is equal to about 1/760th of an atmosphere. One other component we should mention is the knockout pot. The knockout pot takes any condensation of oil in the vacuum line and returns it to the vacuum chamber so that it doesn't enter into the vacuum pump. The knockout pot is located directly above the vacuum pump. Now we've been through the entire diagram. If you ever want to refer to it, it can be found in the manual that is kept with the machine. Knowing the components of the Blue Goose should greatly help you understand how to properly run the machine. If you have any questions, you can refer to the manual or email me at erskaggs@aep.com.